Hello everyone, I'm Paolo Melchiorre and I'm very happy to be here with you, even if remotely. In this talk, we'll see together how to build web maps from scratch using Django and PostGIS. And if you are asking yourself what type of maps we can build with Django, let's see an example right away. These maps show mountain peaks all around the world. We all use maps like this every day in web or mobile application. I built this map with Django and PostGIS. In this talk, we'll see together how to build a map like that, but first I'll present myself. I'm Paolo Melchiorre and I'm the CTO of 20tab, a digital product company based in Italy. I'm a software engineer and a long-time Python backend developer. After using Django for a few years, I became a contributor to the project. I also really like hiking in the mountains, so in this talk, I decided to build with you a map where I can put all mountain peaks I've reached. I took this photo from the starting point of one of my last hike. I was in the Italian Apennines and the sun has not yet risen, but in the distance there is the Adriatic Sea. The making of this map will be a bit like this hike. We'll start from easy stretch and then we'll go up in altitude. But let's start from the basic about web maps. A web map have many features. It can be static or dynamic. You can interact with it or you can only view it. The map can use raster or vector tiles to represent the surface. Usually, the data is stored in a special database, and a web map will use a JavaScript library to show data on your web maps. On Wikipedia, regarding web maps, we can read that web map is the process of using the maps delivered by a geographic information system on the internet. But implementing a geographic information system from scratch is beyond the scope of this talk. To do this, as you can imagine, we are going to use Django, my preferred Python-based web framework. The requirements to create our map with Django are a stable and supported version of Python and the latest stable version of Django itself. In my example, I've installed it in a virtual environment. To create the My Map project, I switch to my project directory and then use the start project Django command. The basic files of our project will be created for us. After switching to the My Map directory, we create our markers app with the Django startup command. Again, all the necessary files will be created for us. Now we have to activate our markers application by inserting its name in the list of the installed apps in the setting file, like at this point, we can proceed to insert in the markers views file a new template view for the page of our map. In the markers template directory, we can now create a template file for our map. For now, we add only usual boilerplate with a title but without any body content. In the markers URL file, we must now add the path to view our map using its template view. As a last step, we include in turn the URL file of the marker app in that of the project. We just made our first view in Django, but it will show only a blank page, so we can move on to something more challenging. I took this photo after half an hour walking in the dark. You can see the sunrise in the distance. We are about to start the high altitude path. As for our hike, something will begin to be seen in our project as well. In fact, we'll add a blank map to our page using the Leaflet library. Leaflet is one of the most used JavaScript libraries for web maps. It's a free software and it's desktop and mobile friendly. Leaflet is very light. It has a very good documentation that you can read online. To use Leaflet, we need to link in the head its JavaScript and CSS module in our template. In addition, using the Django static template tag, we also link our custom CSS file. In the body, we need also a div tag with a specific ID and our custom JavaScript file, which we are going to create now. We add our CSS file in the static directory, and inside it, we add only the basic rule to show a full screen map. In our JavaScript file, we add the code to view our map. Using the defined variables in this file, we initialize an OpenStreetMap layer. We hook the newly defined layer to our map. The last statement sets a map view that mostly contains the whole world, with the maximum zoom level possible. We can now start our Django project with the run server command, and we can finally visit our map page in the browser. Okay, we just created an empty map with Django, and the result is pretty much what you see now. A map without markers showing the whole world. This photo shows the crossroad at the end of the first part of my hike, just before a very challenging uphill stretch. The signs have risen for a while and the landscape is visible around. Likewise, after having visualized our map, we will now start with a bit more elaborate part, writing more code to create our markers and display them. It's time to get to know and activate GeoDjango, the Django geographic module. Django added geographic functionality a few years ago in the country GIS module, with specific fields, database backends, special queries, and also admin integration. Since then, many new useful features have been added every year until the latest version. Before activating it, we need to install some requirements. A mandatory GeoDjango requirement is GDAL. It's an OSGeo library for reading and writing raster and vector geospatial data formats. It's released with a free software license and it has a variety of useful command line for data translation and processing. To easily install GDAL on a Debian-based system, you can use the apt package manager. We can now activate GeoDjango by adding the contrib GIS module to the installed apps in our project settings. To use GeoDjango correctly, we need to change our database engine and use one of the compatible database backend. In this talk, for a more complete example, we decide to start using Specialized, the special extension to SQLite, which is the Django default backend database. It provides vector geodatabase functionality and it's released with a free software license. It has a simple architecture, a complete database in an ordinary file. As before, on a Debian-based system, we can install the Specialized package using the apt package manager. So let's add Specialized as a database backend. In our project setting, leaving the rest of the code unchanged and setting the default engine like that. We can now define our marker model to store a location and a simple name. Our two fields are both mandatory. The location is a simple point field, and we'll use the name to represent the model. We can now generate a new database migration and then apply it to our database. To easily insert new markers in the map, we use the Django admin interface. We define a marker admin class by inheriting from the GIS model admin class, which uses the OpenStreetMap layer in its widget. Now we can create a new super user to access the admin interface after starting the project locally. Finally, we can start our Django project with the run server command as before and visit our admin section in the browser. Here is the page for inserting the markers in our admin. As you can see, we have a text field to enter the name and a GIS widget that we can use to manually navigate the map and then manually define our point in the space before saving it. After having added more markers in the admin, we can finally show them in our map. We can do that by adding the information in our view. Here, we are retrieving all the markers from the database and converting them to GeoJSON format before adding them to the context of our view. The value of the markers key in the context dictionary will be something like that, a GeoJSON generated file. In our template, we use the JSON script template tag to securely add our markers to our page. So let's edit now our JavaScript file and store the GeoJSON in a variable. Starting from this variable, we build a layer for our map and we extract also the name of the single marker. Finally, we add the layer in our map by setting the view to contain all the data. Finally, we can start again our project with the run server command and see our markers in the map page. In this map, we see the few markers I uploaded through the admin. They are inside the page code, but the loading is still fluid and very fast. You can also see the pop-up on the markers of the peak, and if we add a lot of markers to show, our map loading will be much slower than that, and Leaflet will have a harder time rendering it. In this case, we need a better solution to handle that. This photo shows a beautiful landscape that came to my side at the end of a challenging climb. The highest peak began to be seen, but there are still challenging passages before reaching the summit. We then continue implementing the final version, our map, like in the hike. First, let's start using PostGIS as a new backend engine. PostGIS is a Postgres extension, and it's also the best database backend for GeoDjango. It internally integrates spatial data and has spatial data types, indexes, and functions. In this chart, I've synthesized the compatibility table of the open source geographic backend supported by GeoDjango. In the GeoDjango documentation, there are 3 of this table. And as you can see, PostGIS is the only geographic backend that supports 100% of the feature. In order to use PostGIS as a database backend, we need to install the Postgres C client library. As before, you can do it easily with the apt package manager. The Python requirements of our project are increasing, and therefore a good practice is to create a requirement file with a package list. In addition to Django, we are going to use PsychoPG, Django Filter, Django REST Framework, and its geographic add-on. We install all the Python requirements using the Python package installer module. We modify the project database settings, adding the PostGIS engine and the connection parameters of our Postgres database, which you may have locally or remotely or in Docker, for example. We now have to apply again all the migration to the new configured Postgres database. The packages that we use directly in the code of our project are Django REST Framework and its geographic add-on, which we then insert in the list of the installed apps of our project settings as before. So let's create a serializer for our marker class. Inheriting from REST Framework GIS serializer, we only have to define the optional fields to be shown as additional properties, the geographical field location, and the model marker. Our intention here is to expose our markers via a RESTful API, and to do so we define a read-only viewset. We set the location as a field to filter our markers, and then a filter based on boundbox. We also return all our marker instances without any filter. In the markers application, we define the URL of our new endpoint using the Django REST Framework default router to create our map. Finally, we add to the definition of the URL of our project a new path for the API that includes the path just specified for our markers app. After finishing our RESTful API, we move on to update our JavaScript file. As we no longer have the data preloaded in our page, we no longer have a way to position the maps so that it contains all the markers. So we try to locate user through the browser that will ask them to share their location. In the positive case, we'll use the shared location to center the map. In the negative case, we locate them on an arbitrary point in the map with a low zoom level. By no longer loading the marker directly on the page, we therefore ask our endpoint to return only the marker of the specific displayed area, passed as a boundbox string. To build the marker layer, we ask our endpoint for data asynchronously and extract the properties we want to show in the pop-ups. We invoke this flow every time the user stops moving on the map. In this way, our query will retrieve only a minimum number of data from the database, and the response to the browser will be lighter and faster. And finally, here is our complete map. In this example, we can see how the markers in a specific map area look. And then I show you a quick demo I recorded this morning. It's no high resolution recording, but it's only permit us to show how things are loading, and in the developer area, how requests and response are invoked. So let's play it. The loading takes place in a very fluid way because the number of calls occur only when the movements on the map stop, and therefore the data traffic is reduced to the essential, as well as the rendering of the marker carried out by Leaflet. As our map project, the hike also reached its final destination. Unfortunately, the view in the photo is a bit covered, but we can finally add the new marker to the map of our Django project. It was one of the longest hikes I ever made, and I hope to be able to do new ones soon. There are also many other features that can be added in the future in this type of map. For example, marker customization and pop-ups to show more information, marker filtering based on relational data, clustering, both in front end to improve the visualization and backend to make the loading of data more efficient. We can also use geocoding services to add marker locations starting from the address, and so on. At the end of the talk, before saying goodbye, I want to share with you some tips based on my experience as a map developer with Django. The first one is to read the documentation in the Django website directly, because it's full of information about GeoDjango. Read also the detail about geographical queries in the PostGIS website, because it helps you to understand how things work at lower level. Read also the source code of both projects in GitHub, because there is something you can learn only from the code. And last but not least, I suggest you to search for questions on Stack Exchange, but try to answer them by yourself and not reading directly the answer. Last but not least, you can also study this presentation because it's released with a Creative Commons license. In 20 tab, we have developed many maps with Django. You can find more about our open source project and our pythonic works using this context. And finally, to find out more about my personal work with PostGIS and GeoDjango, use all my contacts here. With this QR code, you can download this presentation directly from my website. Thanks again for having me and join the other talk in the conference. Ciao a tutti.